right, so this is again us kind of extending our knowledge using what we did in our momentum unit to look at angular momentum. So it gives us a lot of information, but what we really need is just the graph. So back in our momentum unit, we said, okay, we have this idea that our change in momentum equals our force times our change in time. And then we also said, hey, like we can create a graph that tells us the same idea. If we graph force and time, then our area underneath, we call that the impulse, and that's really like our change in momentum. So anytime we have this positive area, we have a positive change in momentum. We have negative area, that's a negative change in momentum, or a change in momentum in the negative direction. So what we're looking at here is, well, our change in angular momentum, as I said in an earlier video explanation, is the same idea just with our angular components. So instead of force, we have torque, and then time is the same. So time is still time. So what we really have is the same idea. We're just graphing torque versus change in time. So we want to know when we have the greatest uh, angular momentum. So throughout this whole entire motion, we are gaining this positive area. So we're never decreasing our angular momentum. It's always going the same direction, and we're always increasing it. So really, we have the greatest angular momentum at the furthest time because this positive area is accruing, we're gaining this positive area this whole time. So from 0 to 2.5 seconds, we are gaining positive area. So the more positive area we have, the more change in angular momentum we have. So at 2.5 seconds, we have the greatest change in angular momentum because we have the greatest area.